Welcome to Mysterious Mars. In the videos in this channel, you'll get to see Mars in a way you likely have never seen it before. My name is Ben, and I'll be your host as we explore this rather interesting planet. Once you've spent time getting to know Mars, you realize Mars is a really strange place. It has a lot of surprising and interesting things going on its surface. But you wouldn't know that from the kinds of images we typically see in articles about Mars, such as these images here. These images are pretty and somewhat interesting, but as I've looked at these sorts of images over the years, I've often had the sense that there's a hidden depth to them, that if we could somehow burrow more deeply into these images, we'd find all kinds of wonderful and fascinating things hidden there. I began to wonder if it was somehow possible to have more detailed versions of this imagery. This launched me into something of a research project to try and answer that question. But before I get further into that, I'd like to take a moment to talk about where these images come from. While I will be showing some rover imagery, most of the imagery you'll be viewing in these videos comes from the high-res camera on the Mars Reconnaissance Orbiter. The Mars Reconnaissance Orbiter is a satellite in orbit around Mars. The high-res camera is an amazing feat of engineering. It can capture an incredible amount of detail, as you'll be seeing in these videos. I know there are spy satellites with greater capabilities, but HiRISE definitely holds its own in the public space. You can find out more about the HiRISE program here. So how detailed can HiRISE imagery be? And how does what we typically see for high-res images measure up to its full capabilities? Here, for an example, is an image we saw a little earlier. And here is a more detailed version of it. At first glance, this version of the image may not seem quite as exciting because it's not in color like the first version was. But it is interesting for another reason, and that is because it contains much more detail. But it's hard to gauge this without seeing the two images side by side. So we'll go ahead and juxtapose them. Here we have the images side by side with similar zoom factors. As you can see, the image on the left is quite a bit muddier than the image on the right. As we zoom in further, this difference becomes even more noticeable. Note the elongated object here. For scale reference, it's about 7 meters or 20 feet in length. If you were there in person, you could poke your head into the hole in the end of it and see what's inside there. This is just one example of the cool stuff you can start to see when you have this more detailed imagery. The imagery I present in these videos, for the most part, won't be pretty, but it will be rather intriguing. I guess you could say the color image is pretty but shallow. To be fair, you can download more detailed imagery from the HiRISE site if you want to and know how to. I will be doing a tutorial video on what some of the options are if you want to download these images for yourself. And I do recommend doing that in part to make sure I'm not lying about the things I'm showing in these images, or possibly manufacturing things in Photoshop. But my skills in that kind of thing aren't the greatest, and I'm guessing at least some of you could see through such attempts on my part. I always like to verify things for myself, so I always recommend others do likewise. If you don't feel like bothering with that, that's fine also. But the more eyes we can get on these things, the better, and that's much of my goal here. You may be wondering why there are these differences in how detailed this imagery can be. That's a good question that has a complicated answer. It's important to understand that all these images began life as chunks of binary data. Humans can't do anything useful with these images in their original form. That original data has to go through a complex development chain. This is an involved process with many stages to it. Each of these stages has various dials and knobs you can turn that control this process as it unfolds. The tweaking of those various dials and knobs can result in final output images that may look rather different from each other, depending on the goals of whomever is driving the process. For example, simply deciding to produce a color image versus a monochrome image will reduce the level of detail in that final image. There can be some ways around that, but generally speaking, this is the case. And that's why just about all the imagery I'll be presenting here will be monochrome. When we review the images we saw at the beginning of this video, I think it's safe to say that whomever generated these images didn't have fine detail as their highest priority. I can't speak for them as to what their ultimate goal was in the production of these images, but that doesn't really matter. The good news is that anyone can download the original data and process it for their own purposes. So what I'm presenting here in these videos is my own processing of that data, and I'm processing it with the goal of recovering as much detail as possible. Here are some of the tools I've used to accomplish this. Most of them are open source and free, except for Photoshop. I also wrote a couple of my own Mac apps to help automate the overall process. It's quite tedious and time-consuming to do this work by hand, so automation is necessary if you're wanting to do this at scale. Here is what the process looks like in action. The simplified version is that it involves downloading a bunch of files and then running an assortment of programs against those files all in the proper order. Once we're done with the initial phase of processing, we end up with something that tends to look like this. I can understand if you're not overly impressed with the result, but we're not done with the process. So let's move forward another step. We're starting to have some interesting detail now. If I toggle the two images back and forth, you can map the stronger lines in the first version to the second version. I see some things in this area of the image that look rather interesting. So let's enhance and enlarge some more. This is just like in those crime thriller TV shows and movies where someone is always being instructed to enhance that, and there's a lot of zooming and Hollywood computer noises, and then they can read a license plate. It's the same concept here, only real, and I don't do all the computer noise things. Although if people feel they need that for some reason, I can probably work it in. So now that we have this capability, we can start applying it to all kinds of different terrain across Mars and see what the surface looks like at a relatively high level of detail. And one of the cool things about Mars is that it possesses a great variety of different kinds of terrain. Here's a small sample of some of those terrain types we'll be examining more closely. While there certainly is a significant variation of surface features across Mars, as you see an ever-increasing amount of the Martian surface, you very quickly begin to notice recurring themes. And what I mean by this is that similar types of terrain patterns keep showing up in different places around Mars. At first, this may seem rather obvious if you're talking about dunes and craters and rock layers and so forth, but that's actually not what I'm talking about here. What I have in mind is more subtle than those kinds of features. And often it isn't something that becomes apparent until you view the terrain through this higher level of detail. Broadly speaking, probably the best term for what I'm talking about is pattern terrain. As the name suggests, it's terrain that has some kind of recognizable pattern to it. Here is an example of this. This terrain has a lot of straight segments that have highly orthogonal relations to each other. This is another example of this pattern, even if in other ways this image is relatively different than the prior one. We'll do a little trick here and invert the image, which will allow us to see the linear features much more clearly. As before, we can enhance and enlarge it even further to get an even clearer look at these very interesting features. This is one of the more common terrain patterns on the surface of Mars that we'll be running into frequently in upcoming videos. In a similar vein, there are a number of other fascinating patterns that we'll also be getting acquainted with. With all that said, I have a few closing thoughts on how this project has unfolded for me over time. When I reflect back on my progress in undertaking this project, and where I was before I started it and where I am now, I had success in being able to produce more detailed Mars imagery than what we typically see in popular media, and that feels like a worthwhile accomplishment. On the other hand, I feel like I failed. And I feel like I failed because I've ended up in a place where I know far less about what's going on the surface of Mars than I did before I started this undertaking. I realize you're not supposed to know less about a given subject after you engage in significant study of it in some manner, but reality works out kind of strange sometimes. The more I study it, the less I know about it. Paradox is rather typical of Mars. And anyone who decides to take a closer look at this planet is going to quickly run into a never-ending series of surprises and paradoxes. So please join me in exploring some of these mysteries, and maybe you can even help untangle some of them. That's all I have for this introductory video. If you find this content interesting, please subscribe to my channel, and thank you for watching.